Hello everyone. In previous lecture we had discussed all about the different tests like standard proctor test, modified proctor test, and about the OMC optimum moisture content, and also about the zero air boil line. So in this lecture we are going to solve some problem based on these formulas. So let us start or solve a problem. The question is, a laboratory compaction test on soil having specific gravity Z equal to 2.68 gave a maximum dry density of 1.82 gram per centimeter cube and water content of 17%. Determine the degree of saturation, air content and percentage air void at the maximum dry density. What would be the theoretical maximum dry density and dry unit weight corresponding to zero air voids at the optimum water content? So this is our question. So let us find out what are given in the question. It is given G equal to 2.68, maximum dry density rho d max we noted as like this 1.82 gram per centimeter cube, water content W equal to 17% equal to 0.17, degree of saturation SR equal to question mark, air content SC equal to question mark, percentage air void NA equal to question mark. Then theoretical maximum dry density rho d theoretical max equal to question mark. For zero air void this is NA equal to 0 at OMC we know. Next is dry unit weight, this is gamma d equal to question mark for zero air void, that means NA equal to 0 at OMC. These are the conditions at which we have to find out the rho d theoretical maximum and also dry unit weight, this is gamma d. So let us find out one by one. So first we know the relation, this is rho d max equal to Z rho w by 1 plus Wg by Sr. So from that Z is given, rho w value we know, W value is given, Z value also given, so unknown is Sr. So from that we can calculate Sr value. So we cross multiply it, by cross multiplying it 1 plus Wg by Sr we keep it in left side and 0 W by rho d max in right side. Again Wg by Sr equal to 0 W by rho d max minus 1. We take this one to the right side. So finally Sr equal to Wg by 0 W by rho d max minus 1. So all the values are given in the question. So 0.17 into 2.68 whole divided by 2.68 into 1. Rho W value is 1 gram per centimeter cube we know. Divided by 1.82 minus 1. This is equal to 0.964. This is equal to 96.4%. So this is our answer. One answer is completed. Next again we know the relation between SC and SR. So SC equal to 1 minus SR. We put the decimal value here, 1 minus 0.964. This is equal to 0.036. Again equal to 3.6%. We know air content also represent in percentage. So we convert this also in percentage. This is another answer. Next. Again rho d equal to another formula we know, 1 minus Na Z rho w by 1 plus Wg. So rho d equal to 1.82 equal to 1 minus Na 2.68 into 1 by 1 plus 0.17 into 2.68. But Na is unknown, we keep it constant here. So after calculation 1.82 equal to 2.68 minus 2.68 Na divided by 1.455. Again equal to cross multiply it, 2.68 minus 2.68 Na equal to 1.82 into 1.455. So from that after calculation we find Na equal to 0.014 and multiplying 100 we found 1.4%. Next again we have to find out theoretical maximum dry density. So rho d theoretical Ts max equal to 0 W by 1 plus Wg, but here it is given, a condition is given that Na equal to 0. So according to this we have to calculate it. So we put all the values, 2.68 into 1 by 1 plus 2.68 into 0.17. This is equal to 1.841 gram per centimeter cube. Again dry unit weight gamma d equal to rho d theoretical into theoretical max into Z We know the relation gamma equal to rho into G. So 1.84 into 9.81, this is equal to 18.06 kilonewton per meter cube. So this is another answer. So the problem was completed. Now types of field compaction equipment. So different equipments or different compaction equipments which are used to compact the soil are as follows, like smooth wheeled steel drum rollers, pneumatic tire rollers, ship's foot rollers, impact rollers, vibrating rollers or drum, hand operated vibrating plate and rammer compactors. So these are the basic equipments which we use for the compaction of soil. So now we discuss one by one briefly, as this is a long question. Types of field compaction equipment. This is an important long question. So you have to write briefly in the exam. So first one, smooth wheeled steel drum roller, like this as shown in this figure. This is the smooth wheeled drum roller, steel, as this is made up of steel. So steel drum roller. Its capacity is 20 kilonewton to 200 kilonewton. It is again self-propelled or towed. Then it is suitable for well-graded sand, gravel, silt of low plasticity. This roller is used, and it is unsuitable for uniform sand, silty sand and soft clay. Next is pneumatic tire rollers, like this pneumatic tire rollers. Usually 2 axles carrying rubber tired wheels for full width of track, and here dead load is added to give a weight of 100 to 400 kilonewton. And this pneumatic tire roller is suitable for coarse soil, also for fine soils. And this roller is unsuitable for very soft clay and highly variable soil. The number 3, seafoot roller, like this. As shown in the figure, the roller is like this. These are known as seafoot, so that its name is seafoot roller. This roller also self-propelled or towed, and here the drum is fitted with projecting club-shaped feet, like this, to provide kneading action or to provide better kneading to the soil. This type projecting club-shaped feet are provided here. Its weight is 50 to 80 kilonewton, and this roller is suitable for fine-grained soil, sand and gravel with considerable fines. Number 4, impact roller. Here the compaction by static pressure combined with impact of pentagonal roller, like this. The roller are of pentagonal, like this. Different shapes are available, not only pentagonal. Higher impact energy breaks soil lump and provides kneading action. This roller gives better kneading action. Number 5, vibrating roller or drum, like this. Here the roller drum fitted with vibratory motion, and the levels and smoothens roads here. Number 6, hand operated vibrating plate and a rammer compactor. Hand operated means, as the handle shows the figure, this one. So these are the hand operated. Wherever necessary, the compaction is necessary, we move there. And it is used for backfilling trenches, smaller construction work and less accessible locations, as it compact very less area of soil. So these are basically used for smaller construction work. So these are the basic equipments which are used to compaction of soil. Let us discuss types of consolidation. So consolidation of soil are divided mainly into 3 types: initial consolidation, primary consolidation and secondary consolidation. So this is also a long question. Types of consolidation, again individually a short question or maybe of short note type what is initial consolidation or primary or secondary consolidation. So let us discuss one by one. So first is initial consolidation. So the reduction in volume of soil just after the application of fluid is called initial consolidation. And but for saturated soil, the initial consolidation is mainly due to compression of solid particles. So this is known as initial consolidation. Next is primary consolidation. So after completion of the initial consolidation, we go for primary consolidation. For further reduction of volume occurs due to drainage of water from the voids of soil. So in fine grained soil, the primary consolidation occurs for a long time due to low permeability of fine grained soil. But in coarse grained soil, primary consolidation occurs for a short period of time, or it takes less time, as in case of coarse grained soil the permeability is high. And the primary consolidation is the most important component of the total consolidation process. That means this primary consolidation plays a vital role among the three consolidation process. The last one is secondary consolidation. Here the reduction in volume continues at a very low rate even after primary consolidation is known as secondary consolidation. So the major part of the water which is present within the soil are discharged or drained in the primary consolidation process. So that it takes a very slow process to remove all the water present within the voids of soil. So this much. And this is a graph which shows the time in log scale in the x-axis, deformation in the y-axis, and here it shows the stage 1. This is initial compression or consolidation. Stage 2. This is the major or vital role. Whatever I told, that primary consolidation takes a very vital role. So that this is the stage 2 primary consolidation. And the third one is the secondary consolidation. After primary, we go for the secondary consolidation to drain out the remaining water present in the voids of soil. So for this lecture, this much. In next lecture, we will again discuss an interesting thing. This is spring analogy. So thank you.